We are solving quadratics. We're going to be doing several methods. We've already learned how to solve by factoring, but I wanted to give you an opportunity to practice. Here's some basic information. Very few quadratics are factorable, so you won't be able to solve by factoring very often, but when you can, it's a quick and easy method. Here are the steps. You can follow these steps. The answers that you get will either be real or rational. We'll talk about that in a minute. But here's the problem. X squared minus 10x plus 31 equals 10. So stop the video and see if you can follow these steps to solve that system by factoring. Step number one, I set it equal to 0. It was set equal to 10, so I subtracted 10 from both sides. These were the two terms that were like. The 31 and the 10 were like, so I put the positive 31 and the negative 10 together and got positive 21. Now the quadratic is set equal to 0, so I assessed that this was going to be an easy trinomial. So because it had a coefficient of 1, so I did my factor sum table. Factors of 21 that had a sum of negative 10. There were only two factors of 21, 21 and 1 and 7 and 3. It was a pretty short list. I needed a negative 10, so I knew these numbers had to be a negative, and negative times a negative gives me a positive 21. But when you sum negative 21 and negative 1, you get negative 22. Sum negative 7 and negative 3, you get negative 10. So since this is an easy trinomial, the negative 7 goes in one parentheses, the negative 3 goes in the other parentheses. I just completed step number 2. Step number 3 says set each factor equal to 0. That's called using the zero product property. We talked about that earlier in factoring. And then step number 4 is to solve each factor. So trying to solve means get the x by itself. So I add 7 to both sides, I add 3 to both sides. And what that means is that my x-intercepts are real numbers. They're not only real, but in this particular case, they're rationals. If this had been an AC method problem, we would have gotten a fraction right here. I'll try to do one in class to practice, help you practice solving using the AC method. But you will get x-intercepts. If it's factorable, you're going to get an x-intercept that's either a real number or a fraction, a rational number. When you are solving by taking the square root of both sides, your equation is going to be limited to those that have a b of 0. In other words, you will not have a b value. An example here. Let me change colors real quick. Here's 8x squared plus 1 equals 17. Okay, you've got a squared term, you've got a constant term, there's no x, and you've got another constant term. So there's no term that has an x on it. So that means that this term right here has no b. We've got a squared term, and then we've got two constants. So that means that we will be able to solve this problem by taking the square root of both sides. So we're going to go through the steps. Steps number 1 is to isolate the x squared. That means we got to get the x squared by itself. So I'm going to start by moving that constant out of the way. X squared equals 17 minus 1, that equals 16. Isolate the x squared, get rid of the coefficient. That says 8 times x. So I'm going to do the opposite of times. I'm going to divide. That's going to divide out, leaving me 1x squared equals 2. And when I get 1x squared equals 2, I'm now going to take the square root of both sides. I'm going to take the square root of this. I'm going to take the square root of this. Don't forget the plus or minus. And the plus or minus comes in when we take the square root of x squared as x, and the square root of 2. We can't take the square root of 2. It's a pretty simple number, but we do have to have both a positive and a negative value of the square root of 2. This is an irrational number. We talked about that at the beginning of the week, where we know that it's a decimal value. The square root of 2, we learned on our notes, is a number somewhere between 1 and 2. If you put it on a number line, this is the x-axis, this is the y-axis. It's about 1 point. Let's see, I'm going to look on my calculator. I'm going to take the square root of 2, and it tells me that it's about 1.4. So if this is 1 and this is 2, on the number line, the square root of 2 is going to be somewhere right there in the middle. That's the positive value of the square root of 2. The negative value is going to be, well, about halfway between -1 and -2. So this parabola right here is going to cross the x-axis at this point right here and this point right here, and it's going to be looking something like this. We know it's opening up because 8 is positive. If we solved this part right here, for 0, it'd be x squared minus 16 equals 0. So we would know that it would be crossing the y-axis down here at -16. So that kind of solidifies that it was opening up. And this dot right here is the positive square root of 2, and this dot right here is the negative square root of 2. And that's pretty much all there is to solve by taking the square root of both sides. Isolate the quadratic, isolate the x squared term. That usually involves adding and subtracting and then maybe dividing, and then take the square root of both sides.